Let's start chapter number 12, Preparation of Salts. Some historical significance of salts, origin of salary. Historically, people were paid with salt. Trade routes, salt was crucial trading commodity before. Ancient processing methods of salt include evaporating seawater, harvesting from salt lakes, underground mining, rock salt quarrying. Biological importance of salt. It is essential for human life, fundamental to taste sensation, critical for body electrolyte balance. Types of salt can be determined based on its solubility characteristics. So, soluble salts dissolve readily in water, while insoluble salts minimal water dissolution. Example of soluble salt is sodium chloride, and for insoluble salts we have silver chloride, barium sulfate, etc. Now let's talk about salt preparation methods. Method A is through titration. Uses precise acid-alkali reactions. It requires burette indicator, precise volume measurement. Then another method is excess reagent reaction method. It uses excess metal, base, or carbonate, involves reacting acid with solid substances, removing excess solid after reaction. Next is precipitation method. It is used for creating insoluble salts. The process is mix two soluble salt solutions, form insoluble precipitate, and then filter and collect solid. Key chemical concept. Ionic equations, simplified representation of reactions, shows only participating ions. Water of crystallization. Water molecules chemically combined in salt crystals distinguishes between hydrated substances that contains chemically bound water and anhydrous substances where there is no water content. Some precipitation reaction example, important consideration, salt preparation techniques such as always use excess reagent, carefully remove excess solid, avoid overheating during crystal drying. Practical applications, food preservation, chemical analysis, and industrial processes. Solubility rules table. So, salt type is sodium salt. Solubility is highly soluble. Example is sodium chloride. Then we have potassium salt. They are also highly soluble, and examples are potassium nitrate. Then we have calcium salts, partially soluble, and examples are calcium sulfate. After that, we have silver salts. They are generally insoluble, and example is silver chloride. Some key takeaways here is salt are diverse ionic compounds. Multiple preparation methods are there. Solubility varies significantly. Precise technique is crucial in salt synthesis. Now, let's talk about salt and their preparations, definition, and importance of salt. So, salt is an ionic compound formed by replacing hydrogen in an acid with a metal or ammonium ions. Crucial in everyday life and various industrial processes, found in minerals, biological systems, and industrial applications. Key types of salts, table of common salts and their uses, very important for exam perspective. Salt such as ammonium chloride. The parent acid is hydrochloric acid. Characteristics is that they have white crystals. Primary use is fertilizers and batteries. Then we have sodium carbonate. Parent acid is carbonic acid. Characteristics is white crystals, powder, and it used in cleaning, water softening. Then we have copper 2 sulfate. Parent acid is sulfuric acid. They are having blue crystals and then used in fungicides. Now let's talk about solubility of salts, solubility patterns. So soluble salts are all sodium, potassium and ammonium salts are soluble salts. All nitrates are soluble salts. Most of the chlorides and sulfates are also soluble salts. Insoluble salts, almost all carbonates, silver chloride, barium sulfate, these all are insoluble salts examples. Now let's talk about solubility consideration. Solubility impact salt preparation method. Solubility measured in gram per decimeter cube. Some salts have limited solubility such as calcium hydroxide. Now let's talk about hydrated substances. Water of crystallization definition is water molecules chemically combined in crystal structure. Affects crystal shape, color and structural properties. Hydration states hydrated means it contains chemically combined water. Anhydrous means no water in the chemical structure. Example of hydration is when any substance is there such as CuSO4 and then it has some water molecules attached with it. So it is an hydrated salt. Now dehydration process. Heating dries off water of crystallization. Crystals lose shape and become powder. Chemical transformation occurs. Some salt preparation methods, soluble salt preparation can be done through neutralization of acid with excess metal, excess insoluble base, excess insoluble carbonate, and titration method with acid and alkali can also be used. Then we have insoluble salt preparation. You can use precipitation technique or you can use any specific chemical reactions to form the desired salt. Some key terminologies important here are number one, soluble, which means substance that dissolve in solvent. Insoluble, substance that do not dissolve in solvent. Hydrated substance chemically combined with water. Anhydrates without chemically combined with water. Some careful practical considerations like careful heating of hydrated salt, understanding solubility rules, selecting appropriate preparation method is crucial. Biological significance here is that sodium chloride is essential for muscle contraction, which is a salt. Sodium chloride is a salt, NaCl. It is important in everyday life, in muscle contraction, in nerve impulse conduction, osmosis regulation, and digestion aid. Now, preparing soluble salt with some experiments. So, we have the stages of reaction. Initial reaction option, it can react with metal oxide, metal carbonate. The key principle that is used here is always to use excess solid reactant. Wait until reaction is complete. No more gas production. Indicators of completion can be no more hydrogen gas is producing now, litmus paper no longer changes color, and there is no more carbon dioxide evolution. Now, in filtration and crystallization processes, filtration steps are remove excess solid reactant, collect clear solution which is filtrate, use filter funnel and filter paper. Crystallization techniques include careful evaporating solution, use sand tray or gentle heating, cool solution to form crystals, and then filter and dry the crystals. Next method we have titration method for salt preparation. Titration procedure. The key components include burette, volumetric pipette, indicators such as methyl orange or thymolphethylene, and conical flask. Titration steps. First is preparation. Fill burette with acid. Add known volume of alkali to flask and then add indicator. Then in neutralization, slowly add acid to alkali. Swill flask to mix. Watch for indicator color change, identify